Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving a very nice quartic equation with complex numbers. Now I call this equation nice because it allows us to use multiple methods, and the solution methods are actually pretty interesting. What would you use to solve an equation like this? Would you use the Quartic formula? That would definitely be one of the solutions, but I don't think I'm going to use it because that would take too long. Actually, never mind. I changed my mind. I think I'll use it. But I won't use it. I will use it and not use it. You'll see in a little bit what I'm talking about. Okay. So let's go ahead and try to solve this problem with a couple different methods. We have z to the fourth power and then 6 minus z squared as a quantity raised to the second power, and their sum is negative 14. Great. Two positive quantities being added, and we get a negative answer. That could only happen in the complex world. Not in the real world, as you know, no square is negative in the real world, right? But we are in a different world, and that world is called a plus bi, right? Hopefully you know that because it's the name of this channel. You probably came from another channel called Cyber Math, because I have another channel called Cyber Math that is cyber with an S, okay? And to answer some questions that you do before you ask, I'm not from Siberia. Cyber means something else. Okay, anyways, so how do you solve an equation like this? There's a couple of ways to do it. So one of them is just going to be, I guess, substitution. I mean, it doesn't have to be, but let's start with that. First method, I'm going to use substitution. And guess what? I want to replace this thing with something, maybe w, right? If I do it, I'm going to get z to the fourth plus w squared equals negative 14. But that's also going to give me 6 minus z squared equals w, which then I can write as z squared plus w equals 6. So this equation and that equation, we could probably work these two together, right? Somehow. Like treat them as polynomials and use some identities. But I have a better idea. I think it's better, so you don't have to use, substitution more than once. Instead of you calling that w, because they gave us a quartic and a quadratic, which are kind of incompatible, right? For some reason. So why don't we just call that w squared, because that would give me a quartic or a fourth power. Make sense? And not only that, it's also going to give me another nice thing. We'll see. Let's take a look. Once you replace 6 minus z squared with w squared, and you're going to square that one more time, you're going to get w to the fourth power. You see, now we're adding fourth powers, which is nice, much better. And from the substitution, we get 6 minus z squared equals w squared, which implies z squared plus w squared, if you put this on the right-hand side, equals 6. Of course, you switch sides. Let's get rid of this, because it's the same thing. And let's bring these closer, like moving them by being lazy, okay? Now, we have a nice system. Do you see that? It is nice because we have the sum of fourth powers and we have the sum of squares. So here's what we can do. We can use Vieta's formulas. We can use some identities, symmetric polynomials or something like that. Or I can't remember exactly, but there's the S1, S2, S3, something like that. But anyways, here's what I'm going to do. I'm going to take this and square both sides. Z squared plus w squared equals 36. And if you expand it, z to the fourth plus w to the fourth plus 2z squared w squared equals 36. I know that this is negative 14, so I can sub. That gives me 2z squared w squared equals 50. Yay, I got a positive answer. Well, this can happen with complex numbers, and that is equal to 25. This is kind of nice because I can square root it easily, and there are two solutions, right? ZW can be 5, or ZW can be negative 5. This may or may not be very important if we're going to deal with Z squared W squared directly, but let's just record it for future, okay? Or we're going to use this directly. Let's see. How would you go about solving a system like this? You know what I would do? I would take this and square that. What would that give you? Z to the fourth plus W to the fourth plus 2Z squared W squared. You see, I knew that. I wasn't going to use ZW, but that's okay. We tried. Now, this would give me z to the fourth plus w to the fourth is negative 14. I already know that, right? And this one is this one 25. So when you multiply by 2, that's going to become 50. 50 minus 13 is 50 minus 14, I mean, is 36. So from here, we get the following, which means this is plus minus 6. Awesome. We're going to use both. But guess what? Wait a minute. Isn't this weird? Like z squared plus w squared is also 6. Are you serious? Maybe that's the case. Who knows? Okay. Now, if this is 6 and this is 6, what's going to happen? Then by adding these two, we're going to get z squared equals 6, which means z can be plus minus root 6 or w equals 0. And, I mean, right? Not or, but and. Okay. Does that make sense at all? Because zw cannot be 5 then or negative 5. There's something wrong with this. I probably messed up somewhere. I think I forgot. Oh, yes. Sorry about that. I just realized I was supposed to use a minus sign. Uh-oh. A glitch. And now we have different number. Okay, well, we're going to just erase this. And guess what? I'm not going to cut this part, so you'll get to see my mistakes. Some people like it, some people don't. Let me know what you think. But anyways, you're going to see the correction. Now, we have negative 14 minus 50, which is negative 64. Awesome. That's still a perfect square, and that's just perfect. Now, we can go ahead and square root both sides, and that's going to give us imaginary numbers, either 8i or negative 8i. And of course, along with the other equation, this is going to make more sense, because remember, z squared plus w squared was negative 14, right? Now we can do the following. Add these up, we get 2z squared equals negative 14 plus 8i. From here, z squared is negative 7 plus 4i. I hope I didn't mess this up one more time. I hope so, because negative 7 plus 4i did not look like a perfect square to me, but maybe it is. You know what? I think this is going to become, I feel like this looks like negative 16 plus 9, which kind of tells me this is probably 3 plus 4i squared. But then that will give me 24i, not 4i. So that seems problematic, but anyways, we're going to do another method, so hopefully this will be fixed, maybe with the other approach. So let's go ahead and take a look at the other approach, which I believe is going to be better. At least, probably, it'll be correct at least, right? Okay, cool. Now, here's the second method, which should have been the first, but expanded. You know what? This will give you a nice equation, even though it looks, I mean, it is quartic, but there's no z in the equation. Okay? Oh, kind of 4 is that notability? Come on, calm down. So that's 36 minus 12z squared plus z to the fourth power equals negative 14. Now, if you add these up, you're going to get 2z to the fourth. Sometimes notability or Apple Pencil does that. I don't know why. Some people said it's static electricity, something like that. I don't know what it is, but it tends to do that sometimes when the video is especially. I think it's a warning that the video is too long. Okay, anyways, get the idea. Now let's put everything on the same side. Divide by 2. You get z to the fourth minus 6z squared minus 25 equals 0. And yay, this is quartic, but at the same time, it's bi-quadratic, right? If you call this w, you're going to get w squared minus 6w plus 25 equals 0. And we can use the quadratic formula and then go back to find z. Maybe z values are not going to be nice. Let's find w at least. Negative b plus minus the square root of b squared minus 4ac. Again, we get the infamous negative 64, right? Or the famous negative 64. That will be 8i, 6 plus minus 8i divided by 2. And I think I'm going to end up with the same answer, which would make sense. This is going to be 3 plus minus 4i. Wait a minute. When I solved it the other way, z squared, because w is z squared, right? Obviously. So I did not get 3 plus minus 4i, but I got negative 7. You know what? I probably made a mistake somewhere. I'm not exactly sure what it is, but you can hopefully figure that out and help me out. Z squared plus w squared was not negative 14, maybe? No, it was. No, it was 6, exactly. Okay, now I get it. It was 6, so this was supposed to be 6, and then everything will be nice from there. Okay, you get the idea. We fixed it. Now, from here, what are we going to do? For example, if z squared is equal to 3 plus 4i, you kind of need to think about the square of which complex number is 3 plus 4i. And let me tell you, I think it is 2 plus I. Am I right? Yes. You know what? Because if you square this, you're going to get that number. But there's another solution, negative 2 minus I. And of course, this is for this one. 3 minus 4i, you're going to get negative 2. Oops, no, I mean, it's, wait a minute. We need a minus sign, so it's going to be 2 plus I. 2 plus I and the opposite, negative 2 minus I. Let's go ahead and check something out with Wolfram Alpha. The graph, they don't intersect because there are no real solutions. That's it. Sorry. This brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.